Hi class, welcome to week 4 of our class. And this week our primary topic will be covering hypothesis testing with a little bit of confidence interval stuff sprinkled in there. So what I want to do in this video here is I want to show you how to use StatCrunch to do hypothesis testing with what they call the p-value approach. And I have 3 problems picked out from your homework to walk you through. So the first problem I want to walk through is problem number 6. Okay, so it says test the hypothesis using the p-value approach. Okay, and what the p-value approach is, it's basically the probability you would observe more extreme results if the null hypothesis is true. And what they do is they give you a level of significance that's alpha. So they say alpha is equal to 0.05. And if your p-value is less than your alpha, then you reject the null. And if your p-value is greater than alpha, you fail to reject the null. All right, so it says be sure to verify the requirements of the test. And it says here's the hypothesis. We have the null hypothesis that the population proportion, P, that's important to know that this is a population proportion problem, is equal to 0.7. And we're saying versus the alternative is we want to look for evidence to say, hey, no way, the population proportion is greater than 0.7. It tells you the sample size, the number of individuals who have that characteristic, and the level of significance. So the first thing it says, the first part it says, is n times p naught times 1 minus p naught greater than or equal to 10? Well, p naught is the value here. P is equal to 0.7. Right, that's the believed population proportion. So grabbing your calculator, you go n, which is 250, times p naught, well, that's the value in the null, 0.7, times 1 minus 0.7. So looks like that's equal to 52.5, which is greater than or equal to 10. So yes. So that's good. Great. Now it says use technology to find the p-value, and it says round to 3 decimal places. Well, what you'll want to use here is you'll want to go to question help and you want to use StatCrunch. When you load up StatCrunch here, you're going to go stat, and whenever you're dealing with population proportion, you're going to go to proportion stats, one sample, and we have a summary of the data. So it said the number of successes, if you look back here, was 195. That's your X. The number of observations, that's your sample size, was 250. And the first thing down here is going to do hypothesis test or confidence interval. We want hypothesis test. And the null was 0.7. And the alternative was no way it's greater than 0.7. So it always defaults to be 0.5. You just have to change it to whatever it says in the problem. So after that, what I'm going to do is I'm going to hit compute. And if you look over here, right there at the end, that's my p-value. So 0.00, it said round to 3 decimal places, so it's 0.003. So I'm going to plug that in here. 0.003. And look, I got it right. So then the next one says blank the null hypothesis. So we're going to reject the null hypothesis because our p-value is less than alpha. And that's it, we got it. So notice this problem, if you try to do it by hand, the formulas in the class, it's really hard. But notice that with StatCrunch, I was able to find the p-value very quickly in roughly 30 seconds or so. All right, let me show you another problem from your homework. All right, number 11. And this one says, based on interviews with 98 Sars patients, so Sars was an old, or not an old, but it was a virus that got notoriety a few years ago. It stands for severe acute respiratory syndrome. Anyway, so we have 98 Sars patients. And researchers found the mean incubation period was 5 days. So an incubation period is the time that the virus, you come in contact with the virus until you start to show symptoms. So it was 5 days with a standard deviation of 14.4 days. Okay. Well, based on this information, construct a 95% confidence interval for the mean incubation period of the SARS virus. And then let's interpret the interval. Okay. So the first one says find the lower bound. Well, you're going to go to question help. You're going to go to StatCrunch. And notice here, I'll go back and show you the problem, but the problem says the researchers found that the mean was 5 days, and from this sample, all right, of 98 SARS patients, the standard deviation was 14.4. All right, so that tells me it's going to be a t-stats problem. So go to t-stats, one sample with summary. So the sample mean was 5 days. The sample standard deviation was 14.4. There were 98 SARS patients. And if you look back at the problem, they want us to construct a 95% confidence interval from you. So I'm going to click the 95% button. I'm going to hit compute. So over here was our lower limit. They said go to 2 decimal places. So it's 2.11. Got that right. Great. And the upper limit was 7.7, or excuse me, 7.89 when you round it. Got it. Awesome. All right, so interpret the interval and choose the correct one. Well, what this means, all right, so 95% confidence interval says we're 95% confident that the mean lies between the lower and upper bounds. Okay, so it looks like the first one here. So it says there is a 95% confidence that the mean incubation period lies between the lower and upper bounds of the interval. We got it. All right, let's just do one more quick problem. All right, this one is to do with hypothesis testing for a mean. So it says test the null that the mean is equal to 20 versus the alternative that the mean is less than 20. And it says a simple random sample of size n is equal to 19 is obtained from a population that is known to be normally distributed. All right, that's great. All right, so the first one says find the test statistic. Well, what you want to do here is you want to go to question help and you want to load up your StatCrunch again. So they're telling you that X bar, the sample mean, was 18.4, and S, the sample standard deviation, was 4. So you're going to go to stat. You're going to go to t-stat, one sample with summary. So the sample mean was 18.4. The sample standard deviation was 4. The sample size was 19. And we were testing that the mean is equal to 20. So changing that to 20 versus less than 20. So just plugging in the relevant information. You're just going to hit compute. And this right here will tell you everything you need to know. So the problem over here says, first one says, compute the test statistic, round to 2 decimal places. Well, this t-stat here, this negative 1.74, all right, that's our test statistic. All right, so I'm going to take that, copy it, put it right in here, and I got it. Great, nice work. The next one says draw a t-distribution with the area that represents the p-value shaded. Well, since this is a less than, that tells me it's a left-tailed test. So it's going to be C here, which is great. Approximate the p-value. Well, let's go back to our StatCrunch output. It's 0.0491. So that's right about here. It's between 0.025 and 0.05. Great. So if the researcher decides to test the hypothesis that the alpha equals 0.05 level of significance, will the researcher reject the null? Well, since the p-value here is less than 0.05, it's close, right? The researcher will reject the null hypothesis since the p-value is less than alpha. Just like that. So I encourage you this week to continue to play around with StatCrunch. As you see, it can take some of these problems and really make them so that they can be done rather quickly. As always, if you have any questions, let me know and I will answer them in the classroom.